Good morning. Welcome to Thursday. We are going to be talking about volume today. So I got a couple jokes for you. The first one is a um, three shapes. The one's a cube. We got a triangle and a circle, and it says three-dimensional. What makes you so spatial? That's a pun based on two-dimensional versus three-dimensional objects. The triangle is base and height. That's how we find our area. And then the circle's just a circle, not a sphere. And then, of course, there's the cube, which has three dimensions: length, width, and height. Okay, great little joke there. I'm sure you'll spend all day thinking about that one. And there's this one for today's lesson on volume. The teacher's got the formula up there on the board in a picture. And then some kid out there in the audience, is that you, says, "What if someone hits the mute button?" Wrong kind of volume, kid. So I don't know how they're related. It's kind of strange that we have volume and volume in the English language. They're probably related in some way, but I don't know that. So anyway, let's get right on to the work for today. But first, one quick thing. I had someone ask the question on this, and I didn't quite realize that you might have that question. If we were in class, this would have been asked early on, and we'd take care of it. But this paper's kind of confusing here because you have to realize that each circle lines up with the line right next to it. So this circle here, which has a line from A to B, uh, A to B is just a radius, right? So for number one, you'd write in the word radius. And this is a word bank. And it's the 4 words to choose from to identify all of these. So it probably should have had a box around it or moved down somewhere, because one being radius right here kind of messes you up a little bit, thinking that, okay, the next one's going to be one of these, and then I've got extras. So that's a little explanation for that. 2 is this circle, 3, 4, 5, 6. It's first, second, third, fourth, fifth, sixth. So it's logically correct, but I can see why that would be confusing. Let's look at the bottom one there. It's number 6. Now the directions say to tell, match the word that best describes the line segment AB. And you've got 2 line segments there. But AB is one that goes from a point out here to across here and not through the center. And so that's going to be, for number 6, will be a chord. Right. Now, yesterday we talked about the word diameter. Diameters are chords too. So if you wanted to, for number 5, if you know that that's the diameter, and you want to say diameter, you could also put chord as well. But diameter is the one I'm looking for. Diameter is more specific there. Okay. So you've got 6 different answers, but only 4 different words to choose from. So some of them will be duplicates. All right, on to the paper for today. This is one that's in your packet that's just an extra. It's the one that I wanted to use to demonstrate for you on volume. I like this one. I pulled it out of one of the a magazine for math teachers that was around for a while, and it used treats, chocolate bars, fudge, lemon squares, chocolate cake, marshmallow treats as their rectangular prisms. These are what these are, rectangular prisms. They're like cubes, but stretched. They're based on rectangles instead of squares. Cubes are based on squares. So volume is something that you've worked with in 5th grade. Hopefully we don't have to spend a whole lot of time on that anyway, but the formula for any rectangular prism or any box is volume equals length times width times height, just like that comic told you earlier. And you did this a lot in 5th grade. 5th graders have actually done this ahead of you, because we're using this as a review for surface area and to see the difference of these two. But so they've done this just recently. So if you need help, ask a 5th grader. That's a horrible thing to say, isn't it? All right. So every problem, and I'm just picking the marshmallow treats here. They sound better than brownies at the moment. every problem you just are plugging in these three numbers to do that. Now normally I would make you write this out on paper, because a big part of 6th grade is getting ready for the linear equations and solving inequalities and stuff of 7th grade and 8th grade. And so in 6th grade, my task is to help you start organizing and showing your work. Kids hate that in 6th grade, because it's like this one. Yeah, I can do this in my head. Well, maybe you can. If you multiply the length and the width first, you get 72. 72 times 3, 21, 6, 216. That's going to be your number. So yeah, you probably could do that. So 216 inches for your volume, which that's 216 inches cubed. So that means that if you chunk a little cube out of here, if your cube comes out of this part, then it's going to be, that's not a very good cube, then your cube is going to be 1 inch by 1 inch, and that means that there's 216 of those. So this really isn't very hard at all, the second part of those problems. Okay, now again, if I was to have you in class on this, we'd write this out on notebook paper. We'd put our length 9, we'd put our width 8, and we'd put our height 3, and then you'd multiply 72 times 3, or 216. I hope that's still the right answer. And then you apply your units, inches times inches times inches. There's 3 of them this time. So it would be, instead of writing inches times inches times inches, it's much easier to write inches cubed, inches to the 3rd exponent. So that's how you'd solve those problems. Now, we're not going to spend a lot of time on that, because you know that it's basically you multiply the 3 values. Okay, now I didn't realize that you might have this paper in your set. That was a mistake if it's there. Last time I cheated you out of one paper, and this time I'm giving you an extra. I don't know which is worse, not have the paper or have an extra. But anyway, if you want to do that one, it's pretty easy. You can turn it in. Looks like there's some extra credit opportunity there. If you want to do that, it's the volume of rectangular prisms. Okay, and be sure to read the directions, but it shouldn't be that difficult for you. Make sure you use the units on that one. Looks like every single one of them centimeters cubed. So then you would have easy units there. Okay, all right, so the one that we're really wanting to work on today is one that first 3 problems are always easy for kids that know their volume formula. Okay, so let's do the one with the fractions. That's the one that we need to make sure that you know. Now, decimals, multiplying decimals by decimals, make sure that you put your decimal in the right place. If you're one of those kids that's going to use a calculator, you need to think about your decimal placement, but I think your calculator's going to do all that for you. So I guess you can do that. All right, so this is my key, and I'll put my name on it. By the way, that does help when you guys put your name on every page in your packet, because I take them apart, put them in stacks, and then I grade the individual papers all together. So I'll grade every 6th grader's volume of surface area page once, and then I'll flip it over and grade the other one, which this is only a one-sided paper, but it helps when you put your names on all of them. All right, so number 3. Let's see if I can zoom in a little bit so we can work on this one a little better. Number 3 has 3 values, and we're finding the volume. So our volume formula, length times width times height. Hopefully that'll be ingrained in your head. Our length, you get to choose if you want this to be the length or this the width. This is almost always height. So let's do this right here. So that's 2 2/3. 2 2/3 is our length, and our width is 3 1/2. And then our height is 6. So again, it really doesn't matter what order those are in. So if you had these 2 flipped or something and you're confused about that, don't worry too much about that. That is a perfectly legal way to do it because of the commutative property. You can move those around. All right, so on this problem, I'm probably going to multiply these two first. There, if you do see that you can multiply these two first, might make it a little easier for you. But instead, I'm going to go ahead and do these with you, and I'm going to put it over in the margin over here and do 2 2/3 times 3 1/2, and I'm going to make mixed numbers out of these. So 3 times 2 is 6, 7, 8. 8/3, 6, 7 over 2. Can I cross cancel? Yeah, I actually can. Here's 4. Here's 1. 4 times 7 is 28. So it's going to be 28 over 3. And I'm just going to leave it like that because now I'm going to go 28 times 3, or sorry, 28 over 3 times 6 over 1. And look, I can cross cancel again. Turns that into a 2, that into a 1. 28 times 2 is 56 over 1, or my final answer is going to be 56. 56 what? Inches, inches, inches. So it's 56 inches cubed. Okay, that looks like a hard problem. The hard part of it is not the volume. That's not what the part that we're working on is the volume, putting those in order. The hard part to you guys is probably remembering, how do I multiply by fractions? Well, we've done that recently. I mean, it's been 3 or 4 weeks now, but that should still be something that you know how to do, and then get a final answer out there that makes sense. Okay, that's pretty important because down on this problem right here, this is a real life problem. This is like, when are we ever going to use this? Well, some of you are going to need to know how much of something goes into something else. Now, this is a truck problem. Truck drivers might need to know this, although, and this isn't meant to offend anybody, but the people loading the truck usually aren't the ones that figure out the information of where this goes in. There's a lot of people in logistics, is what they call that. People that are in an office figuring out, hey, if I can load that truck with 500 boxes, it's a lot more efficient than if I just try to guess how many and put it in there, and they make a lot more money. Those people in logistics make more money than the poor guy loading the truck. The manual labor is pretty tough, but the person that knows this stuff is going to make them more money. I think that's not always the case. So let's get to solving this problem. It's actually 2 problems in one. You have to find the volume of the truck, and you have to find the volume of the box. Then you have to figure out their relationship. So first, let's find the volume of the truck. So we'll put that up here because we're going to want to know that, and then the volume of the box. So over here, we're going to start to find the volume of the truck. So volume equals length times width times height. The length is this one, right? Or we want to call this the length. Okay, that's the same thing as the 15-foot length. Yeah, that's probably more appropriate for the length. The width of the truck here is 7.5. So I'm going to use an X to keep that a little less confusing and move my paper where it's supposed to be. And then I'm going to multiply by my height. Well, the height is also 7.5. Okay, so this is a good one for the calculator. I learned the other day not to put my phone on the screen because I get email notifications and texts and things that aren't all that important, but they often don't apply. So I'm just going to go and multiply all 3 numbers together, and hopefully you get the same thing I do. 843, 75. Calculators don't lie, but they also will only do what you put in. So if I made a mistake, then it would record it wrong. So I double check almost always. And I found that number again. So we've got feet, cubic feet in there. So we're breaking this down to the single cube feet, right? And there's 843 and 75 hundredths of a cube feet. So if the boxes were cube feet, you'd have 843 boxes that would fit in there without problem, and then you could get 3/4 of a box in there. Hopefully it's not something vital to be divided up if you're going to try to squeeze that in here. Okay, so then here's the box. It's not a cube foot. It's actually something different, but it is a cube, and so we're going to have 2.5 times 2.5 times 2.5. Notice I'm just dropping off those zeros because they don't mean anything, and it's just going to mess up my paper if I do it. Or that's the same thing as 2.5 cubed, right? With the feet cubed. No calculation needed here. I could do that on my calculator. If you have, here, we'll do this. If you have your calculator set to this mode, then you have a regular calculator. But you can actually, if you're on a phone or something, you can split it to this, and then you can use the X to the Y button. So let me show you that real quick. You would put in, we've got 2.5, so I'm going to put in 2.5. I'm going to put X to the Y to the third, and it's there, 15.625. But I notice here there's an X to the third button already. There's X squared and then there's X cubed. So if I do that, 2.5 X cubed, then it's already set for you, and the same number comes up. So that would be 15.625, and so we've got that. Now, what do we do with these two? Well, remember, you're trying to figure out how many of these go in there. So it's kind of like if this was full, you'd take this off each time, right? Put this on, so you're basically figuring out this times what equals this, or in reverse, this divided by this number equals what. So that's the easy operation there, is to do the division. So I'm going to go ahead and divide, flip my calculator back. I'm going to do 843.75. I'm going to divide that by the number, or by the size of the boxes, 15.625, and that equals exactly 54. There's no remainder there, so 54, and it's 54 what? Some people like to put feet squared, and that means that they're not answering the question, because what it's asking you is, how many boxes? Well, that's how we did this division problem, right? This divided by this equals 54. 54 boxes. Okay, that one's kind of tough. You tend to spend some time on that one. There's a lot of thinking about a two-step problem, and some kids get stuck there. They just don't quite, I don't know, don't have the thought process down to solve that one. So that's kind of tough. All right, so this is the main paper I want you to do today. It's 4 problems, but they're 4 tough ones. We did 2 of them together. Actually, the first 2 should not be tough for you. So maybe this is an easy day if you watch the video. If you haven't watched the video, can you remember, or can you imagine your friends that haven't watched how tough this is going to be for them? Yeah, so tell them, if they complain or anything, say, well, did you watch the video? He did it for us. But hopefully you're not just copying it down. You're actually understanding and listening to what's going on too. One more thing I want to tell you before I close the video. I know that some of you are doing some things like, probably most of you, because this is the way we do things in our society now, is you're putting on the video and then you're going to clean your closet, or sort out your playing cards, or whatever you're doing. Maybe you're playing Fortnite while you're watching the video, and then when mom or grandma or grandpa or Uncle Betty comes in, then you say, oh yeah, I watched that video, but I still have trouble. Make sure that when you're watching the video, you're watching the video. I know I'm not the most entertaining fellow in the world, and I got this weird voice today for some reason. But put your brain on the problem and engage with what the lesson is. Okay? All right, enough preaching from me. You guys have a great rest of your Thursday, And Friday, it's kind of a tough assignment, but once you're done with it, you got the weekend, and we have something a little bit more fun, I think, scheduled for next week. Okay, email me if you have problems.